First factor method is the greatest common factor. And this is what we always look for first. And this works for any number of terms. So I'm just going to put always try first. This should sound familiar because you covered it in Algebra 1. And some of you might have even seen it in like middle school and Math 3. But the greatest common factor is basically what you can divide the terms by, every term. So we have two terms. We have 3x squared and we have 24x. And we see what can we divide them by. So like we have two numbers, we have 3 and 24. So what can we divide 3 and 24 by?
3.
3. We can divide both of them by 3. Okay, is there anything else that's the same in both of those terms?
There is one x.
They both have an x. Yeah, so if you look at the first term, actually has x squared, and the second term has just an x, but they both have an x in common. So what we're essentially doing is let me erase this. We are dividing each term by the GCF. So we're dividing each term by 3x. So when we do that, we put the GCF in the front, and then all the leftovers are going to come after it. So what is 3x squared divided by 3x?
X.
X. 3 divided by 3 is 1. And x squared has two x's, and we're taking an x away, so we're left with x to the first, which is just x. What is 24 divided by 3?
8.
8. Okay, and then the x, there's a 24x. When we divide by x, it's actually like taking the x away, so you're left with just 8. So this is our final answer for this when we factor out the GCF. Okay, and then I just want to show what this really is doing is it's like undoing distribution. So it'd be like if you were to distribute, 3x times x is 3x squared. 3x times negative 8 is negative 24x. When you distribute, you should get right back to your original expression. That should happen. That's because factoring is like undoing distribution. So it's kind of a quick way to check to make sure you did it right. But this stuff in the blue, that's not part of your answer. It's kind of like a quick check. But your answer is 3x times x minus 8. Okay, so that was factoring when there's two terms, the GCF. Now, what about when there's four terms? Let's try one more. We're still looking for the GCF. This time we gotta look at four things. What is the number that we can divide all four terms by? Is there any number we can divide 3, 24, 2, and 5 by?
1.
1. The biggest number is 1. All right, so 1. And then is there any letter they have in common?
X.
All four have an X. Okay, if you look closely, we actually have 2 X's here, 1 X here, 4 X's, and then 3 X's, because X to the third is like 3 X's, and X to the fourth is like 4 of them. But the most X's that we could take away from all of them is 1, because there's only 1 to take away from our second term. So it's like you can't take 2 X's away when there's only 1 X there. So we're going to put the GCF in front, which is X, and then the leftovers will come after. So 3x squared, if you take away the x, you get 3x. 24x, if you take away the x, you get just minus 24. 2x to the fourth, if you take away one of the x's, you get 2x to the third. And 5x to the third, if you take away 1x, what do you get?
5x squared.
5x squared. Okay, and that's the most we can take away from each of them. Because notice there's no more x's to take away from our second term, so we can't take away another x. That's all we can do. Okay. And that's how the GCF works. You just take away the biggest thing you can from every term. Okay. Our second method we're going to cover today is difference of squares. So GCF is the first thing you look for all the time. And then after that, you're going to kind of look for how many terms are there. When there are two terms, when there's two terms, we check to see if we can do difference of squares. Difference of squares is when the problem is a subtraction of two perfect squares. And I'm just going to list some perfect squares off to the right. So your perfect squares, which I'm going to talk about right over here, are like if you take 1 and you square it, 1 squared is 1. So 1 is a perfect square. If you take 2 and you square it, 2 squared is 4. 4 is a perfect square. If you take 3 and you square it, you get 9. So 9 is a perfect square. Okay, can you think of any other perfect squares?
4 squared.
So what would that be? What's 4 squared?
16.
16. What's the next one after 16?
5 squared.
5
25.
squared, which is 25. 6 squared is 36. 7 squared is 49. Okay, I'm going to go off to the side. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And we can keep going on and on and on. I'm going to stop at 12 just because that's probably high enough. I mean, you might have problems with bigger numbers than that, but your perfect squares are these numbers here. Those are perfect squares. 1, 4, 9, 16, 25. They're perfect squares because you can get them by taking a number times itself. Like 1 times 1, 2 times 2, 3 times 3. So whenever we have two perfect squares subtracted from each other, we can do what's called a difference of squares. So if you look at the first one, x squared is a perfect square because it's x squared. 9 is a perfect square because 3 times 3 is 9. So what we do with this is we actually will find the square root of each. What is the square root of x squared? X. And what is the square root of 9?
3.
So what we end up doing is we break this into two sets of parentheses. So x squared was first, right? And x squared is x times x. 9 comes second. And 9 is 3 times 3. So the x's come first because x times x makes x squared. The 3's come second because 3 times 3 makes 9. And then we put a plus and a minus. Okay? This is your answer. Okay, and I'm going to show you why this works like this. The reason we do this is because let's pretend we were foiling this parentheses now. If we want to check our answer. What is the first term when we do x times x?
X squared.
It's x squared. Okay, when you do the outside, what's x times negative 3?
Negative 3.
When you do the inside, what's 3 times x?
3x.
And when you do the last term, what's 3 times negative 3?
Negative 9.
So if you notice, this inside part and the outside part, What's negative 3 plus 3?
0.
0. Those will cancel. So you're left with x squared minus 9. So that's why difference of squares works that way. So that's why you take the square root of the first term, square root of the second term, and you can just write your answer like this. Okay, I don't expect you to FOIL it like that every time. I just was showing why that works. Okay? So if you look at number 2, or the one off to the right there, this is a 2-step problem. Let's double check, is there a GCF? I see some heads nodding, those of your camera on. There is a GCF, right? What can you divide 4 and 100 by?
4.
4.
There's a GCF of 4. So we're going to put 4 in the front, and the leftovers come after. When you divide by 4, you'll get x squared, and 100 divided by 4 is 25. So you get 4, x squared minus 25. Now, if you look at just the parenthesis part, just right here, what do you notice about x squared and 25? They're both what?
Difference of squares.
We're going to do a difference of squares because they're both perfect squares. All right, so I'm going to change colors. We're going to do the square root of x squared and the square root of 25 because they're both perfect squares. So the square root of x squared is x, and the square root of 25 is 5. So they're perfect squares, which means 2 sets of parentheses. X goes first, because x times x is x squared. The 5 goes second, because 5 times 5 is 25. And we have a plus and a minus. The only difference is we have to bring down our 4. So we end up with 4 times x plus 5, x minus 5. So there are some problems you have to do with GCF and then do difference of squares. And this is one of them. So the GCF is 6, because 6 is the biggest number we can take away from here. They both have x's. What's the most x's you can take away from both? What is the biggest amount of x's you can take from here?
X to the 3rd.
X to the 3rd. So your GCF comes out front. Okay, what is 24 divided by 6? 4. And x to the 3rd, if we took away all the x's, there's none left. If you took away 3, there's none left. 30 divided by 6 is 5. There are 4 x's. You took away 3. How many are left?
1.
So it's just x. So you end up with 6x to the 3rd times 4 minus 5x. And that was just doing a GCF. Take a look there. Number 2. Okay, number 2, check for a GCF. Let's just talk about is there a GCF right here? Something you can divide them both by.
No.
No, there's no GCF. There's nothing you divide 21 and 25 by besides 1. So there's 2 terms. 2 terms means we'll do difference of squares. So go ahead and take a second and try to figure this one out. What do you get when you do difference of squares for this problem? Okay, so I zoomed out so you can look over here. If you look over here, 121 is a perfect square, and so is 25. So we're subtracting 2 perfect squares. So what we're going to do is take the square root of 121. You get 11. You take the square root of 25x squared, and you will get 5x. Because the square root of 25 is 5, the square root of x squared is x. So since 121 comes first, you have to put the 11s first. Since 25x squared comes second, you'll put 5x second. And then we have a plus and a minus. Okay, and that's your answer there. So that's how difference of squares works. Okay, we have 2 more problems left. We'll do these together. Number 3. The first step we always look for is there a GCF? In this case, there is. What is the biggest number you can divide 8 and 72 by?
8.
8.
8.
So we're going to divide these by 8. And the reason I'm looking for the biggest is because you can divide 72 by 2. 72 is divisible by 2, but that wouldn't get you the best answer. We're going to actually divide it by 8 will give us the simplest form. So 8's in the front. X squared minus 9 is the leftovers. Okay. And what do you notice about x squared and 9? They're both what?
Perfect
Differences.
squares.
They're both perfect squares. So now you think, okay, what is the square root of x squared? It's x times x. What is the square root of 9? 3 times 3. And it's a plus and a minus. Okay, and then we just got to bring this 8 down. This 8 has to come down the front. So we end up with 8 times x plus 3 times x minus 3. All right. So again, that was a 2-step one where you had to do GCF and then you had to do a difference of squares. Okay, the last one we're going to cover today is grouping. Grouping happens when there are 4 terms. So whenever there's 4 terms, you check for a GCF and then you try grouping. So let's check for a GCF first. Is there a greatest common factor? A letter they all have in common or a number you can divide them all by?
No.
No, there is not. Because the last term, everyone has an x except for the 8y. So really, we can't do a GCF, so we got to try grouping. How grouping works is there's 4 terms. We're going to group the first 2 terms together and the second 2 terms together like that. Okay, and then what I like to think of it as is I'm going to ignore this for the first part. I'm not even going to look at that. I'm just going to look at the first 2 terms. What is the GCF for the first 2 terms?
3.
3 what?
X.
3x. You can divide 24 and 3 by 3, and they both have an x. So let's do the GCF. 3x comes out front, and the leftovers come after. So 3 divided by 3 is 1. X squared divided by x is x. Okay, what is 24 divided by 3?
8.
8. So it's going to be a minus 8 because it's minus 24 divided by 3 is minus 8. And by the way, the x's, this x, you're taking away an x, so there's no x left. So it's just minus 8. Okay, so we do that, and then what I like to do is think of it as, now I want to ignore this part. Who cares about that part? I want to focus on the second 2 terms. What is the GCF for the second 2 terms? And they both have a y. All right, so there's a plus sign here, so we're going to put plus y. And then after it, we're going to put the leftovers. If you took away a y, you're left with x minus 8. Okay, so this is our new equation after we did the GCF for the 2 groups. Okay, and I'm going to erase this again then. Okay, now if you look at this one, what do you notice is in common here in the 2 terms?
They both have x minus 8.
They both have x minus 8, so what we're going to do is take x minus 8 away from each of these. We're going to take away the x minus 8. So let me go back to pen. X minus 8. And when you take that away, what's left?
3x plus y.
3x plus y. So that's how grouping works. You do a GCF of the first two, a GCF of the second two, and then what happens is you should have something in common, like the x minus 8. You take away the x minus 8 in the front, and then the leftovers come at the end.